Welcome to our channel, my dear students. Today we are going to talk about the previous year, that is last 10 year CBSE Board Chemistry question part 26, in which we are going to discuss about the aldehydes, ketones and carboxylic acid chapter. So here the question number 1 is to predict the product of the following reaction. Just they are asking only the product. We don't want to go for the mechanism. So based on that reactant we have, it's a ketone, and we have a strong oxidizing agent. That oxidizing agent will oxidize the compound. So normally this reaction will be taken place under a strong conditions. So I'll be getting benzoic acid as a product along with carbon dioxide along with water as a product. So here that is nothing but the product formation. And second question is in first question subdivision 2. So one benzoyl chloride will be given, that is acid chloride will be given. The chloride which will be reacting with H2 in presence of palladium. The palladium will be acting as a catalyst. Here barium sulfate will be acting as a poison to avoid further reduction reaction. That is what here I will be getting a product. If suppose if I am writing this hydrogen as HH, this will be leave as HCl, I will be getting a product like this. Okay. So here I will be getting C double band O, H is there. Along with that I will be getting HCl as a product. Here why we used barium sulfate as a poison? Because if I use barium sulfate, this will be getting poison. That's what, this will not undergo further reduction to give benzyl alcohol. So that kind of alcoholic product will not be getting. So further reduced reduction can be avoided by the use of barium sulfate. Okay, this is nothing but a Rosenmund reduction. And next one is how will you convert the following? This question was asked in the year of 2009. So we have to convert ethanol to 3-hydroxy-butanal. So here we have to look it very carefully. Here from alcohol they are asking aldehydes. Moreover here only 2 carbon atoms are there. Here 4 carbon atoms are there. So first we have to convert this into 2 carbon containing aldehydes. How we can do? Say for example, this is CH3. CH2OH. This is ethanol. Okay. So if I'm acidify this or oxidizing this, how we can oxidize it? So we are in need of a very aldehyde next to the alcohol, so that we require very not to be strong oxidizing agent. The weak oxidizing agent like PCC or PDC we can use it. If we use this, so I'll be getting a product CH3CHO. Aldehyde I'll be getting. Okay. So here in this product aldehyde, that is CH3, C double band O, H is there. Suppose 2 carbon containing aldehydes. So if we want to make it as 4 carbon containing butanal, particularly 3-hydroxy-butanal. So I had to use in presence of a base. So I'm going to react with that strong base, dilute sodium hydroxide. That time it will be acting as a condensation reaction. So by the way, I'll be forming aldyl condensation. Here it is a functional group. Here it is a alpha carbon. So aldyl condensation only involving in the presence of alpha hydrogen. So this alpha hydrogen, usually I'll be getting a product like this. What type of product I'll be getting? CH3, CH, here it is OH, here it is CH2 and CHO I'll be getting. This is nothing but a 2,3-hydroxy. This is 1, 2, 3, third question. So 3-hydroxy-butanal, 4 carbon containing aldehyde I'll be getting. I think so you learned about the mechanism in previous class. So if you don't know the mechanism, you please go and watch my previous video regarding aldyl condensation reaction. So I'll be explaining the simple mechanism of regarding this reaction. Okay, are you able to understand, students? So here just by the presence of a base, so the 2 carbon containing aldehydes can be converted into 4 carbon containing hydroxyaldehydes. Okay, and next one is the benzaldehyde to benzophenone. Benzaldehyde, benzophenone. How we can convert this benzaldehyde to benzophenone? How we have to write initially the benzaldehyde. What is the structure of benzaldehyde? This is the structure of benzaldehyde, C double band O, H. What about the benzophenone? How we can write the benzophenone? So benzophenone is nothing but this is the benzophenone. Okay, C double bond O, and one more ring to be substituted here. Benzophenone, I have to get it. Okay, so benzophenone I have to prepare. So initially, how we can do this? So we can do with that oxidation. So if you are doing the oxidation, so it will be forming some compounds. Say for example, if I am taking a benzaldehyde, okay, this is a benzaldehyde, C double bond O, H is there. Okay, suppose if I am oxidizing this, so I will be getting form some type of compounds. What type of compounds? So if aldehyde is getting oxidized, I will be getting a product like acids. COOH is there. Okay, that COOH, if it is react with calcium carbonate salt or calcium oxide salt, so what I'll be getting? CaCO3 I'll be getting. So if it is react with this thing, it will be forming some type of compounds, like say for example I am writing in the equation C6H5COO Ca. This is two times. Okay, so now just by the distillation process, distillation process, I'll be getting a product. So here I can write the product like this, C6H5COO, and then two times COO, C6H5, and what is that? Ca. So in which I'll be getting this calcium and CO3 I'll be getting eliminated. So I'll be getting a product C6H5C double bond O C6H5. That is nothing but our benzophenone. Are you able to understand, students? This is very important one. So we have to react with the calcium salt. That calcium salt we're able to form another calcium salt here. So here our dimer will be getting converted. From that, if you dissolve over that, so I'll be getting the elimination of calcium carbonate. CaCO3 is getting eliminated. Okay, if one CaCO3 is getting eliminated, I'll be getting a product like this. Here we have to use calcium salt. Okay, calcium oxide we can use it, or calcium salt we can use it. And next one is convert the following propanone to propene. This is a wonderful conversion. So propanone, we have to write structure propanone. How we can write this? This is a structure of propanone. CH3, C double bond O, CH3 is there. This is a propanone. So initially we have to reduce it because we have to convert a propene as a product. Propene in the sense CH3 single bond, CH double bond, CH2 is a propene. So from that propanone to propene I have to convert. So initially I have to reduce it. So whether I have to, if you don't know about this concept, how to choose a reducing agent, so please go and watch my previous video, that is how to choose a reducing agent according to the product formation. So here 3 carbon containing aldehydes or ketones, something is there, and same reduced product, same carbon containing number, that is 3 carbon means 3 carbon containing reduced product. If we need to have time, so we need to use such a kind of reagents like sodium borohydrin or lithium aluminum hydride. If I used lithium aluminum hydride, I'll be getting 2-degree alcohol, CH3 CH double bond single bond OH. Here CH3 is there. So if I got this kind of a product, if I acidified in presence of acid, if I react this, so what will be getting? So here this lone pair will come and attack. By the way, here CH3 CH, here OH is there, one more H is added. Because of a donation of electron, it got positive charge. By the way, here also CH3 is there. If it is eliminated as water molecule, because of the breaking of this bond, because of that it got positive charge. Once it got a positive charge, this H plus wants to leave on its own. By that way, I'll be getting a product like this. So here CH3 CH CH2 H is there. Here one positive charge is there. So if we want to neutralize it, this H, it's move as H plus. If it moves as H plus, this got negative charge, this positive and negative will form a double bond. That is what I'll be getting a product like this. Okay. Are you able to understand, students? This is very important one. So propanone to propene. So initially we have to reduce it in the form of alcohol. After that only we have to add acids. By that way we can do dehydration reaction. Okay, and next one is the bromobenzene to 1-phenyl ethanol. So first of all, whenever the conversion is given, you just write the reagent first, a reactant first. So it's a bromobenzene. It's a bromobenzene. And what is the product we need to obtain? 1-phenyl ethanol. So we have to write the ethanol. What is that? CHOH. Okay. Am I right? 1-phenyl ethanol. In first position, phenyl group is there and ethanol is there. So phenyl group is there and ethanol is there. One more thing, CH3. Okay, so this is nothing but a 1-phenyl ethanol. How we can convert this? So here also the same thing. So here I have used bromobenzene. Okay, if it is react with magnesium in presence of a dry ether, so what will be getting? So I will be getting phenyl magnesium bromide. That is magnesium bromide I'll be getting. So this is nothing but a Grignard reagent. In how many carbon I need to add in the chain? So I need to add 2 carbon addition in the chain. That's what I have to use. CH3, C double bond O, H is there. If I use that, so this minus and this will be acting as a 2 place, this bond is getting cleaved and this minus will come and attack this carbon. By that way, I'll be getting a product like this. So what I'll be getting? I'll be getting a product. Initially that is what is that? Here I have to write COH. So here H, here it is CH3. That is our ultimate product. What I'm getting. So here we have to use. Initially, bromobenzene is there. Bromobenzene, which is reacting with magnesium in presence of dry ether, it is getting converted into a Grignard reagent. Once I have a Grignard reagent, I have to add 2 carbon containing aldehyde. Why I have to add 2 carbon containing aldehyde? Because I need to get it as 2 alcohols. If I need to get alcohol, I have to add aldehyde. So here I need a 2 carbon containing alcohol. That's what I have to use, 2 carbon containing aldehydes here. So we have to choose the reagent accordingly. Okay. And next is draw the structure of semi-carbazone of ethanol. So this is very, very important one. So first we have to write the structure of ethanol. That is CH3, C double bond O, H. This is the ethanol structure. And we have to write the structure of semi-carbazone. Semi-carbazone in the sense NH2. So here NH and one C double bond O and NH2 is there. Instead of one hydrogen, CONH2 group is added here. So as we know that this reaction will be conducted in presence of a mild acid only. So we have to maintain a pH in the range of 5. Then only this reaction rate will be in a fast manner. By the way, I'll be getting a product as carbazone. So here, whenever the ammonia derivative is getting reacted with carbonyl compounds or aldehydes and ketones, that time the elimination of water molecule is taking place. Okay, so here also the water molecule is getting eliminated. In this semi-carbazone, which nitrogen will undergo, whether this nitrogen or this nitrogen or this nitrogen will undergo reaction. Initially only these nitrogen will undergo reaction. This is because of that resonance stabilization of these 2 nitrogens. These 2 nitrogens are resonantly stabilized. That is what these will not be involving in the reaction. Only these nitrogen containing hydrogen only involving in the reaction. If you don't know about the concept, please go and watch my previous video. I'll be giving you the cards as well as description section. Go and watch my previous video. You'll be getting good idea about this. I think so you understand very well. So here I will be getting a product that is CH3, CH, double bond, N, NH, C double bond O, NH2. This is the structure of a semi-carbazone of ethanol. So if I am getting a ethanol, so if ethanol is reacting with the semi-carbazide, I will be getting product of semi-carbazone of ethanol. Are you able to understand, students? So I think so you understand very well. So please go forward to others to get benefit. Share my videos. Thank you so much for watching. Don't forget to subscribe my channel. Thank you so much. Thank you once again. Thank you for learning. Share and like this video.